Welcome to solverfy.
Hello students, let's begin with this question. In this question, this reaction is given and the mass of the metal nitrate. That means the mass of the CO cobalt nitrate is given, which is equals to 0.480 gram. Then the molarity of Na2CO3 is given, which is equals to 0.100 molar. Then the volume of the Na2CO3 is given, which is equals to 9.64 ml. So in this question we have to find out the theoretical yield of the cobalt 2 carbonate, that is COCO3. So now firstly we have to find out the moles here. So firstly the moles of the cobalt nitrate is equals to its mass is given. So mass of the CONO3 2, then divided by its molar mass. So now by substituting the values in this formula we get here the moles. So mass is equals to 0.408 gram and its molar mass is equals to 206.95 gram per mole. So when we solve this, we get here the moles of the CONO32. So which is equals to 0.00197 moles. Now then the molarity and the volume of the Na2CO3 is given. So by using the formula that moles of Na2CO3 is equals to the molarity of Na2CO3 multiply by the volume in liters. So now substituting the values in this formula, so molarity is equals to 0.100 moles per liter multiply by 9.64 divided by 1000 liter. So when we solve this, we get here the moles. So now the moles of the sodium carbonate comes to be 0.000964 moles. Now here we have to find out the limiting reagent. So if we see the balanced equation, so 1 mole of Na2CO3, it will react with the 1 mole of 1 mole of the CONO3 2. So now here the moles, so we see the now the moles. So here the moles of Na2CO3, this will be lesser than the moles of the CONO32. So in this case the Na2CO3 is the limiting reagent. So from the balanced equation 1 mole of so 1 mole of Na2CO3, it will be produce the 1 mole of cobalt 2 carbonate. So now here we get the moles of the cobalt carbonate is equals to the moles of the Na2CO3, which is equals to 0.000964 moles. Now we can find out the theoretical yield. We have the moles now. So now the theoretical yield comes to be, so the theoretical yield of the cobalt 2 carbonate is equals to the moles of the cobalt 2 carbonate multiply by its molar mass. So now when we solve this, so moles is equals to 0.000964 moles and its molar mass is 118.94 gram per mole. So when we solve this, we get here the theoretical yield. So now the theoretical yield of the cobalt 2 carbonate is equals to 0.1146 gram. I hope this video is useful for you to understand this problem. Thank you.